Hi class, tonight we're going to cover section 4.6, which deals specifically with right triangle congruence. And when I talk about right triangle congruence, I'm talking about the situation where we're asked to prove that two right triangles are congruent. So, when we're talking about proving that two right triangles are congruent, we already know that we have a congruent angle, right? Because by definition, a right triangle has one right angle, and we know all right angles measure 90 degrees. So we've got one congruent angle. So then we only have to prove two other things are congruent. Because when you think about all the postulates and theorems that we're using, each one of them really only proves three things are congruent. Side, 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 three things. Side, angle, side, three things. Angle, angle, side, three things. Angle, side, angle, three things. So, since we already know that we have a congruent 90-degree angle when we're talking about proving that two right triangles are congruent, we only have to prove two other things to be congruent. So let's start out by making sure that we are talking and labeling, I should say, our triangles in the same way and using the right terminology, because that's what's going to allow us to understand the congruence patterns that we're going to use. So this is just a refresher. Y'all already know this. We know that a hypotenuse is the longest side and it is directly across from the right triangle, or right angle, I should say. And we know that the other two sides are called the legs. So, the four congruence patterns that we can use are leg, leg, hypotenuse angle, leg angle, and hypotenuse leg, named directly after the various sides of a right triangle. So let's start with the first one. When both sets of legs are congruent, we have congruent triangles. So in the example here, if we have triangle ABC and we have triangle DEF, and we know that these two legs are congruent and the other two legs are congruent, we can say that triangle ABC is congruent to triangle DEF. Why? By leg, leg. So that is our first congruent pattern for proving that two right triangles are congruent. All right, let's look at the next pattern. Our next pattern is hypotenuse angle. And this is when the hypotenuse of both triangles and another angle outside of the right angle are congruent. Then we have congruent triangles. So let's look at our example. And once again, we're going to label the first right triangle ABC. Then we'll label the next right triangle DEF. And in this case, we have the hypotenuses of both triangles are congruent, and then another angle. And this other angle would have to be one of the acute angles in the right triangle. So I'm going to just label angle B congruent to angle E. In this case, we can say the triangle ABC is congruent to triangle DEF. y by leg by hypotenuse angle. All right, let's go on to our next theorem, specifically only to right triangles again. So here, all we need to prove leg angle is one leg and one other angle congruent. So let's label this ABC again, and let's label this DEF again. And in this case, let's say the angle B and E are congruent, and the side AB and side DE are congruent. So we've got a leg congruent between the two right triangles and an pair of angles congruent. So we can say the triangle ABC is congruent to triangle DEF, y by leg angle. Okay, or we can say, so here we have DEF, that let's say the same leg is congruent, but the other acute angle, C and F, are congruent, and we can still say that triangle ABC is congruent to triangle DEF by leg angle. So it doesn't matter whether the angle is adjacent to the leg that's congruent or not. In both cases, we can prove that these two right triangles are congruent by leg angle. Next, let's look at the final, or the fourth theorem that we can use to prove that right triangles are congruent. And I'm going to label this ABC again, and this DEF. And this one is called hypotenuse leg. And it says when the hypotenuse of both triangles, and we have a typo here, and one of the two legs is congruent, then we can prove congruence using hypotenuse and leg. So in this case, our hypotenuses of both triangles are congruent. And let's just say that this leg AC is congruent to this leg DF. Well, we can say that triangle ABC is congruent to triangle DEF, y by hypotenuse leg. So that is our last theorem that we can use in our four specifically focused right triangle congruence theorems. All right, so we're going to stop, and I'm going to go on to a part 2 of the video where we'll get into some examples.